Hi, and welcome to my YouTube channel. Today I will be going over how to build a fully functional, yet also simple calculator Android mobile app using the Flutter framework, which utilizes the Dart programming language. Something that I do want to make clear is that Flutter is a framework that can basically translate your code into Apple and Google's respective native scripts, Swift and Java. However, I just used Flutter for an Android mobile app simply because I already set up in a Google developer account and Apple's developer account seems to be a bit of a hassle to set up. But something that you might want to do if you are following along would be to set up Android Studio. Since I personally do not have an Android mobile device, I decided to use Android Studio in order to test and troubleshoot my code. I will be making the assumption that while you are watching this video, you already know a little bit about Flutter. It is a framework that is completely based off of widgets. So everything that you see is a widget. There are definitely a ton of tutorials on how to connect your code. I'm personally using VS Code to Android Studio, and you can also run a command called Flutter Doctor in command line, which should be able to tell you what you're missing from your environment to start coding and to start troubleshooting your code. I will also link Flutter's documentation website in the description, as I probably will be referring to it multiple times within this video. In any case, let's go ahead and actually hop into it. So first things first, in Flutter, you're going to be doing most of your code within the main.dart file. Now, obviously, you can separate your widgets into separate files, but I decided to do all of my code within the main.dart file. I do want to go over the imports that I have up at the top. The first one is fairly standard. However, the second one is where all of the magic happens, and it basically does all the heavy lifting for me when it comes to actually doing the math for my calculator. It automatically parses and evaluates mathematical expressions for me. Moving on, in Flutter, you do need to include a main function, as you can see here, that will actually run your code. Below, that is my stateless widget, which includes a return statement that calls a constructor called calculator here. It then moves on to my stateful widget to explain a little bit of the difference. A widget changes. If a widget changes or is dynamic or can take data, etc., it is stateful. If it's static or doesn't change, it is stateless. Inside of my calculator class here, I do go ahead and call my underscore calculator state, which does extend my calculator. Within my underscore calculator state class here, the first thing that you see is a widget function that is called calc button here. It does take a little bit of input. It takes a string for button text, the color for the button color, and a color for the text color as well. I did build this widget to build other widgets a little bit faster. I found out that I was, just as a calculator has, I was making a lot of buttons, and I figured I could streamline this process by creating a function that builds them for me. It does return a size box, as you can see here, with dimensions that I specified, as well as a button widget right here. When the button is pressed, it calls this function calculation, which is where all of my calculator logic is actually stored, and I will go over shortly. After that, it's just some styling by adding in some additional widgets. And again, you probably want to check out that Flutter documentation. Moving on, if we scroll down a little bit further past this calc button function, we have my widget build function here. There are some standard Flutter widgets here, and again, I would encourage you to go check out their documentation that I will link in the description. But if we move forward, we see that I have a column here, a column widget, where I designate my input and output area. If we go to it within my actual app here, we have my input area there. And if I hit equal, we have my output area here as well. If I hit 9 again, you'll see the output and input area. I do have this where I ask if I should actually hide the input. You'll notice if I ever hit enter, it does hide the input and only show the output. Moving forward, everything else is again standard Flutter widgets that you'll be able to check out using their documentation. Moving down, I do want to show off the row widgets here. So we do have a couple of them, and every single row is what you can see here within my device. So the first row is the all clear button, the delete button, the percent sign, and the division sign here as well. And it goes down the list here. Just as I mentioned earlier, I did build a widget function that will build widgets for me, and this is where it comes into action. So I call this function calc button. I include the button text, the button color, and the text color. For all of the operations, you'll notice that the color is a bit different to add some variety. In the last row, if we scroll all the way down, you'll notice that a button is not quite like the others, and that is the 0 button here. As you can see, the 0 button is a little bit wider, so I decided to hard code this one. It does have pretty much the same layout as the calc button function, and we do use that calc button function a little bit later for the decimal point and the equal sign. But because it is a little bit wider, I did add in this padding here as well. And just like every other button, the 0 button calls the calculation function here with the input of the actual button number or the button text 0. Let's go ahead and move on. The next thing is the calculator logic. So everything above was actually how I just built the framework for this. And now let's go ahead and get into the calculator logic. So I do have a couple of variables here where I will be using and manipulating the user's input. So the first things first, we have an input variable, an output variable. We have the hide input, which is just a Boolean value. So as I showed you earlier, I need to see if I need to actually hide the input or not. We have the output size, which is just a variable that I will be referencing. You'll notice that the output is fairly large here. If I actually go ahead and hit plus or something like that, you'll notice that the output is a little bit smaller now that there is actually input. So I will be referencing that back. And then finally, we have the previous value that I use in several cases to check the last value the user entered. Looking into the calculation function, it does take a value, which will be the button text of whatever button the user hits. The first case covered is if the input is all clear, or AC, it simply sets input and output to empty strings, and it sets the previous value equal to AC, the value. Next is the delete key, and that just simply returns a substring of the user's input minus the last value that they entered. Next is the equal sign here. I have my code set up in a try and catch block in order to handle any errors that I haven't accounted for. In any case, in the try block, I replace any of my x's that the user actually inputs into something that can actually be parsed and used as a mathematical expression. So I use this little asterisk symbol. And then I also replace any of these percent signs with a divide by 100 here. So if I did, let's just say 101% and hit equal, it returns with 1.01. Next, it does set up a parser here, which does actually parse the user's input. And then this right here is where it actually does the math for me. Let's go ahead. Typically, if you want to actually, this is where the output actually gets set and is displayed to the user. And this also if the output ends with a dot or a point zero, given that it's a float or a double, it just goes ahead and removes those. Typically, on a calculator, if a user has an output and they simply press the plus, minus, or any type of operation button, it will have the output automatically assigned to it, and you'll be able to be a part of, be able to be a part of the actual input. I wanted this, but not if the number was too big to prevent overflow. That's why I have this statement. So if the output is greater than 10, the input is just equal to empty, to an empty string, else it will just be the input is equal to the output. And that's why I do need to hide it later on as well. As you can see, I do here, and I change the output size. This is where I actually catch any unexpected errors, again, that I don't handle in my cases, and it simply just outputs error. The next case is if the user enters an operation button. I have a couple things set up here where if the input and output are equal to an empty string and the user selects an operation, it automatically fills in with the number 0. Go ahead and show you that. If I hit plus, it'll be a 0 times and divide as well. Next, a couple of things. I have some cases where if the input ends in an operation, the input just ends up equaling the input, unless it is a minus sign, which I have in these next couple of cases as well. So I'll go ahead and show you that. If we do 8 divided by, if I keep hitting this button, it will not go unless I do minus. So we can actually do a negative number here. And continuing on to the next case here, it is the decimal case. Pretty much everything is going to be copy and paste for most of the operation cases as well. For this one, it does have a different case where if the input ends with a percent sign, you cannot put a decimal point after it. Moving on to if the input is a percent symbol, you can just go ahead and add it to the input here, unless it ends with a percent symbol, in which case the input is simply equal to the input and we're not actually adding the value to the end of it. And the last case here is where the user actually inputs a number. So I have a case where the user cannot enter a number more than 9 numbers. However, if the input does contain an operation, then they can continue doing it up until the length is actually 19. I wanted to sort of limit it at least a little bit. So if the length of the entire input plus the value is greater than 19, then the input is simply equal to the input. Else, we can go ahead and add the value to the end of the input. So if we go ahead and go into this else statement as well, if the input plus the value is greater than 9, then the input is simply equal to the input as it does not contain a operation here. And let me see, also with this one, if it ends in a percent sign, then we aren't able to actually add any numbers. So if I do this here, I won't be able to add any numbers to the end of it. And if it falls in line with everything else there, and no other cases are executed, then at the very end, we can just go ahead and add the value to the end of the input. That about does it for this video, just to show you what my calculator does look like in the App Store here. This is what it looks like. I did get these featured images just using Android Studio. You can just simply snapshot it here, and it should be able to save. My default was the desktop, and also something to check out, which again, I will be linking. But you can definitely check out the docs.flutter.dev, and they show you the complete step-by-step walkthrough of how to build and release an Android mobile app. Thanks so much, and feel free to check out my app. I will probably link that in the description as well. Thanks again, and I hope you have a great rest of your day.